Welcome back. In this video session, we'll actually georeference a scanned map sheet into the UTM coordinate system. And in order to develop the rectification or georeferencing model, what we'll do is use a georeferencing toolbar in Arcmap, and then basically we'll develop what's called links between pixel locations and map coordinates. So basically, when you pull up the georeferencing toolbar, there's this little button here, Add Control Points. And what you'll do is point to the image that you want to georeference and point to some pixel location. And then for that pixel location, give Arcmap the correct map coordinates for that location. So either right mouse click and input the XY map coordinates, or you can double click to some GIS feature to grab the UTM or the map coordinates from that GIS feature. And this will become clearer as we actually do this. So as we develop our georeferencing model, we'll have a link table. So basically, each link represents the pixel XY coordinates and the associated GIS coordinates for that pixel location, and then some residual error between the model predicted X and Y map coordinates and the actual XY map coordinates for that pixel location. So here's an example. We've got our link table and we've got 4 links, and for every link we have what's called a residual error. And what that is we point to a pixel and then we tell Arcmap what the map coordinates are for that pixel location. So it actually knows the actual XY map coordinates for that pixel location. And then based on these 4 links, it develops the georeferencing model. And then using that model, it predicts the XY map coordinates for that location. So the residual error for each link is what's the difference between the actual XY map location and the model or predicted XY map location. So it's that straight line distance. So in this case, we've got 4 links and they all have a residual error of about 0.13. And then the overall model error is what's called a root mean squared error, and that will be the sum of these residual errors squared divided by the number of links and then take the square root of that. So take the residual error, square it, plus the second link residual error, square it, all the way down to the 4th link residual error, square it. Sum those all together, in this case divide by 4 links, and then take the square root. And you would get a total root mean squared error, in this case, of 0.13. And typically your agency will have some guidelines when you do georeferencing. So for example, you need to use at least 10 links and the total root mean squared error has to be less than or equal to half a pixel or something like that. Okay, and once we have a satisfactory model that the root mean squared error is satisfactory and we have enough links scattered throughout our image, we have 2 options. One option is you can go to the georeferencing toolbar and choose Update Georeferencing. And what that does is it simply stores the georeferencing model in a raster world file or a raster header information. So then every time you use that raster in Arcmap, it's smart enough to display it using the georeferencing model. Or you can permanently rectify your raster to some new coordinate system by choosing georeferencing and then the rectify option. And that allows you to output to a totally new raster in the coordinate system that you're georeferencing to. And this will all become clearer as we do this using a simple example in Arcmap. Okay, so if you start Arcmap and you download the data for this week, there's a raster called topoindexsheet.tif. And this is simply a scanned raster that was scanned on just a regular desktop scanner. So if we look at the attributes, the pixel size is 0.004. So that represents a scanning density of 1/250th of an inch. and the coordinate system is unknown. So undefined coordinate system. So basically we have this raster, it's just in scanner inches. And what we want to do is use this raster in the UTM coordinate system. So what we need to do is develop some control points that are in the UTM coordinate system, and then we could go to locations on this raster. So for example, here's a location 68 degrees north, and we could point to locations on the raster and the associated locations in the UTM coordinate system. So this is a topo index sheet for sort of the eastern half of Alaska, and it goes from 153 degrees west to the Canada border with Alaska, which is 141 degrees west. So if you downloaded the data from this week, you'll find a table, and the table is called Geographic Coordinates Locations DBF. So we'll add that table. So these are key locations that we can find on our scanned map. So we've got longitude and latitude for 11 locations. So the first thing we'll do is we'll create a point layer from this table. So the easiest way to do that is if you right mouse click on your table layer and say display XY data. So the X field is the longitude and the Y field is the latitude, and then we need to define what the coordinate system of these fields represents. So if you go to Edit, and then Geographic Coordinates, and then North America, and we want this to be NAD 83, 1983. So that will create a point layer in Geographic Coordinate System, North American Datum in 1983. So if I go right mouse click, zoom to layer, there's my points. Okay, so then what we'll do is we'll project these into the UTM coordinate system zone 6. So I'll search for the project tool, and here it is under features. So we'll project that point layer into some folder, and I'm going to call it locations UTM zone 6 NAD 83. And then my output coordinate system will be NAD 83 UTM zone 6 north. And then OK, and then just close. And okay, so now we have our control points in the UTM coordinate system. So what we'll do is we'll make a new data frame and then insert into that data frame these points that are in the UTM coordinate system. And then we'll drag our topo index sheet into that data frame. And it has an unknown spatial reference, which is fine. So now what we want to do is we'll label these points so we know what the original longitude and latitude is of those points. So to do that, if you go to Labels, we'll label them, and then we're going to use an expression. So I'll make them bold 11, and the expression will be longitude and a space, so a double quote, space, and the field latitude. And then we'll verify that. So that's what we would get as an example. And then just OK, label the features in this layer. OK. So now we know the original longitude and latitude of these UTM points, so we can georeferencing to these UTM points. So then what you would do is just pull up the Georeferencing Toolbar, and I'm going to dock it. So we're going to georeference this TIFF image, and then basically what we'll do is right mouse click, zoom to layer, and we're going to zoom to one of these locations of our points. So I'll zoom to negative 153.70. So zoom to layer, and then 153.70 is right here. So then you would just point to that location. So add control points, point to this location of 153.70, and then we'll zoom to layer for our UTM points, and then go to that same location. and then we'll say, okay, for that pixel location, here's the UTM coordinates. And then we'll repeat the process. So then if we zoom to layer, the next one, zoom out, and you see the points are getting closer to their true location. So then we could simply go, okay, let's do the next one, 14170. So here is 14170. So for that location, we need to find the UTM point. So there's my UTM point. We snap to it. So now the points are getting even closer and closer. So we'll do one more. So 153.64. So 153.64 is here. And the associated UTM coordinate is here. Okay, so carefully develop your 11 links based on these 11 UTM control points, and then in the Georeferencing toolbar, choose Link Table. So here we've got our link table, and we have for each link what the residual error is. So what we want to do is we want to end up with 10 links, and we want to delete any link that has a large residual error. So for example, in this case, my largest residual error is 3,000 meters. So I'll delete this link. So I highlight it and press the delete key, and it redoes a model based on my 10 links. And now my residual errors are all less than 2,000 meters. So in this case, my criteria will be for every link, the residual error should be less than 2,000 meters, and my root mean squared error should be less than 1,500 meters. So it is, so I'm satisfied with the model. So since I'm satisfied with the model, then what I could do is go georeferencing and update georeferencing, would just update the world file or the header information. Or we can create a brand new raster that will be in the UTM coordinate system. So let's do that. So basically we'd choose rectify, and then we'll resample, let's do bilinear interpolation. So the weighted average of the 4 nearest pixels. And then let make my cell size 500. And I will output it to a folder, and I'll call this map index UTM zone 6 NAD83.tiff. Oops, it just wants the workspace. Okay, so I'll output using nearest neighbor. So basically it will just grab whatever pixel is the closest to this in the output raster. And the output raster will be in UTM coordinates, and I'll give it a cell size of 500 meter pixel cell size. And I'll call it map index UTM zone 6 NAD83. And then we'll just save that TIFF. Okay, so let's make a new data frame. And then we'll insert that raster that we rectified in the UTM coordinate system. So map index UTM6, and then just turn it on. So now if we look at the properties, it is in NAD83 UTM zone 6 north. And we could see how well this is being georeferenced by putting in a topo map that I downloaded that's already in the UTM coordinate system. So if we add data, let's add Mount Hayes A1. And let's turn that on. And then just zoom to that layer, Mount Hayes A1. So here's the Mount Hayes A1 topo sheet. And if we check it off, you can see it is in that A1 tile as part of this index. So now we could determine basically for any location, we'll have the UTM coordinate system for any topo map. So here's Mount Hayes A1, and it's located right there in the index sheet. Okay, so that was just a simple example of georeferencing using a scanned map index sheet that was scanned on a desktop scanner. So now instead of being in scanner inches, it's in the UTM coordinate system, which is much more useful for our GIS applications.